In lesson 51, we're talking about imaginary numbers, product of square roots theorem, and Euler's notation and complex numbers. On the first example, A, we simply multiply the square root of 2 times the square root of 3. So on A, that's just the square root of 6. You notice how neither one of the 2 or 3 has a negative symbol. Then on B, the square root of 2, it's actually the square root of negative 2. And what we do with that is split it up. So the square root of 3 right now would stay the same. And then that is the square root of 2 times the square root of a negative 1. And this square root of a negative 1 is what I stands for, or represents. Then I would simply multiply that square root of 3 and square root of 2 just like I did in A, and we'll have the square root of 6i. And that would be our answer on B. On C, we'll notice that they're both negative. Now this time, instead of taking that I out of each one, well, let's go ahead and take the I out of each one. So we'll have the square root of 3i times the square root of 2i. That'll be the square root of 6i squared. Now, I squared would equal the square root of negative 1 squared, which would be a negative 1. So this is actually the square root of 6 times negative 1, which would be the negative square root of 6. And that would be our answer. Okay, in the second example, we're basically taking the i's, or the square root of negative 1, from each of these. On A, that's the square root of 13i, and we just leave it like that because we can't simplify. Then on B, now we can split this up so that it is the square root of 4 times the square root of negative 1. So the square root of 4 is a 2, and that square root of negative 1 is an I, so it's 2i. Then on C, let's split up that negative 2 square root, so square root of 3 times the square root of 2 times the square root of negative 1. So we'd have our square root of 6, and that square root of negative 1 is the I. So it's the square root of 6i. In example 3, we're just combining like terms. So 4 and 2 are like terms, so 4 minus 2 is just a 2. And then I have these i's, 6i and 3i, those are like terms, so that'd be a plus 9i. And then that's our answer because there are no other like terms and we can't simplify. Okay, in example 4, we're again just combining like terms, but we need to get rid of the parentheses before we do so. Now the 4 minus 3i doesn't have anything in front of it, so that's just a 4 minus 3i. And the 6 minus 4i has a positive sign in front of it, or a plus sign, so their signs are going to stay the same. Now on our last one, that has the minus sign, or the negative sign, so all of their signs are going to change. So that'll be a negative 2 plus 5i. And then we can go ahead and get our like terms together. So I'll have a 4, 6, and negative 2. So that'll be an 8. And then I'll have that negative 3i, negative 4i, and a 5i that I can combine together. So that'll be a negative 2i. And that's going to be our answer. in example 5, we need to simplify where these i's are being multiplied together. Now recall that I squared earlier was equal to a -1. So for the 2i, that's going to be a -2, because an I times an I is I squared. Now the 3 has the square root, or the I, which is the square root of -1 times the square root of -1 times the square root of a -1. So this would be the -1 here, because that's 2 of them, the same as the I squared. But then we still have the square root of -1. So we're going to write this as a positive 3i, because that's the I, and that's a -1 that we're multiplying by the 3 that is with it. Okay, the plus 2i will stay the same, the minus 4 will stay the same. Now on this one, we need to take that square root of -1, or I, out. So we'll have a minus 2i. So we just split that up as the square root of 4 times the square root of -1. So that was 2, and that was an I. So that's how I got the 2i. Okay, now we'll just put our like terms together. So that'll be a -6. And then we'll have 3 plus 2 is 5, minus 2 is back to the 3, so plus 3i, and that is our answer. We've combined all our like terms. Okay, in example 6, you'll notice that we have some higher powers here with that 5 and the 3. Now that 3 is the same as this one was up here. So we're going to have a -3i, because it splits up the same way with the negative square root of 1 and the square root of -1. So that'll change the sign, because 3 times the -1 is -3, and then we are left with that I, or the square root of -1. Okay, now the I squared is the same as a -1, so that's going to change the sign of the 2, so it'll be minus 2. Now the 7i we can't simplify or change, we're just going to leave that as it is. The 4 we're going to leave as it is. Now the 5, let's look at how that would split up. So we basically have those 5 i's being multiplied together, which are all the square root of -1. So I'm just writing them out so we can kind of get a visual of this. So for each 2 of these, that's a -1. So we have a -1 times a -1, and then we have an I, because we're left with the square root of -1 still. But when I multiply these 2 -1s together, I'll get a +1, and we're left with that I. So this 2i to the 5th is going to just be the same as a 2i, because I would be multiplying this 1i times the 2. So the 2 would stay the same, and we just have 1i. Now I just combine my like terms. So I'll put my -2 and 4 together, and that'll give me a +2. My -3 and 7 will give me a +4i, and then I'll add the 2 to that, so that'll be +6i. And then that will be our final answer. Now, a chart that kind of helps me, the way I think about this, is if it's an I, it's equal to the square root of -1. If it's an I squared, it equals a -1. If it's an I cubed, it would equal a -I. And if it's I to the 4th power, that equals just a +1. And it keeps going in this rotation. So you can split it up and see how many are left over. Does 4 divide into the number or the power evenly? If it does, then it would make it just a 1. Now if it doesn't, see what's left over, because the 4, there would have been 1 4 and then an I left to make it a 1I. So maybe that will help in solving these equations or simplifying them.